This graph shows data coming from the automation system and correlates the energy transfers that are going on. So right now I've got the reservoir line turned on, the plot turned on, and we can see over time it goes down during the day, and then we can toggle on different components. So this will be the solar heater system. We can see when it kicks on, 0 being off and 1 being on, and we can see if that affects the temperature at all. Right here, which is the middle of the day, let's see, that was midday, in the morning actually, 8 o'clock this morning, it kicked on. However, I did have it unplugged for most of the day. If you check earlier in the video, it was unplugged, and I actually only plugged it on probably at this time, about 2 o'clock today. So the temperature wasn't affected until I actually plugged it in, and then the temperature shot up. Now this is somewhat misleading. It didn't actually go from 14.2 to 14.6. It actually probably went just this high, but due to the properties of the water and how it's mixture and how it varies in temperature from the bottom of the reservoir to the top, wherever the temperature sensor is, I'm not exactly sure, but it was reading actually quite high, higher than normal. I did the math. So yesterday I saw a very, very steep slope going up and then a very steep slope going down, and I thought that's kind of weird how it would go down so fast. The reason is because the hot water from the solar heater eventually mixed with the entire reservoir, and that cooled it down quite a bit. And in fact, I did the math, and to raise the whole reservoir just 1 degree would take about 3 megawatts of energy. And for the sun on a perfectly hot day to generate 300 megawatts of energy, given the area of my solar heater, it would take about 5 days. So there's no way it could have done it in the couple hours of time that I measured it. But nevertheless, it did heat it up some. You can see it does actually work. So yeah, that's the solar water heater system. We can toggle on more of the automation system. We can show how the soil temperature correlates with the reservoir temperature, and the soil temperature just bounces up like crazy. I need to fix that. It's an electrical issue, noise issue. And we can turn on the pump. And we can see the geothermal pump is always on. I've got it set so that it's supposed to only be on if the soil temperature is lower than the reservoir temperature. This shows me that there may be issue with the code, the automation code that controls this, because it looks like the pump's always on. So it's this kind of data that can help me improve the system. And then we can also compare it with the air temperature. And the solar system automation is set up, the algorithm is set up so that the pump only turns on at the exact moment that the air temperature exceeds that of the solar temperature. So if we turn all these off and just do the reservoir and the air temperature, we can see that as soon as they cross, that's when the solar turns on.